W1VLF.
Hey everybody, my name is Paul, W1VLF, and welcome back to the lab. Today is going to be kind of interesting. At least as far as I'm concerned, it will be. I was talking with Glenn, W2BX, Bravo X-Ray. I think he's Fintronics on YouTube. And he had left me a comment, and we got on the telephone and talked. This comment was about the notch filter that I built. Here's an example of it. I'll show you these up close. I got some pictures. So the notch, and he said, geez, he's got a huge AM station a mile away, and he'd like to be able to build a notch filter like this. And I explained that this particular one I made here was out of just crummy components, and that it really didn't have a high Q, which meant that it was going to be very broad. The notch was going to be broad. It wouldn't be just 2 or 3 channels wide. It would be all the way up to 1600 hertz. This was, by the way, this was for the AM broadcast band, if I hadn't mentioned that already. So I was thinking about this, and again, Glenn and I had a couple of telephone calls, and Glenn doesn't have a lot of test equipment. For me, it's easy. I could just go over to the spectrum analyzer and tracking generator, and I could fiddle around and play with the Q and get the notch filter to really do, what we want it to do and not interfere with the whole AM broadcast band. So I downloaded today RSPSA. I'm sorry, I might have screwed that up. Anyway, it's a spectrum analyzer that uses the RSP DX or the RSP Duo. I have both, and I thought, geez, I wonder how well that would work out, and I'd like to demonstrate that. And this would be an easy way for Glenn to be able to, because he's already got the receiver. I believe he's got an SDR DX, SDR Play DX. The question is, well, how will this play out? And what can we really do with this? Now, I'm not an expert at this or any spectrum analyzers for that matter. I can hold my own with what I have here, which is a few thousand, is a USB spectrum analyzer. It's about a $4,000 piece of machinery. But then there's also the micro VNA, and if you don't have either one of those things, what do you do? What do you do if you want to know how well your notch filter or your official AM high pass filter is doing? And I threw this one together too. This is a horrible filter, but it's a low pass filter that cuts off at around 300 kilohertz, and you'll be able to see how bad the pass band is on this one. But I have all these filters, so how are we going to be able to look at those with just a spectrum analyzer? Well, here's the secret. Today's secret right here. Okay, I'm going to take a picture of this. I don't know if this is focusing or not, and I don't really care. But you'll notice later on that this is a noise generator or noise source. This is like 12 or 13 bucks straight out of China. Consists of a noise generating diode that's reverse biased, and then a bunch of MMICs to bring the level up to something that we can work with. So what does a noise generator do? Well, we certainly don't want a noise generator when we're receiving things, but this noise generator has a broad spectrum from maybe 10 kilohertz up to 50 megahertz. I don't remember the exact specs on this. You can go on eBay and find all sorts of different ones. They'll give you the specifications for it. And the noise generator creates just that. Creates around an S9 noise level. Nice and flat, okay? So that anything you put in the path between this output, this SMA output, and the spectrum analyzer that you're using, whether it's a spectrum analyzer, a bench type analyzer, is going to have some effect on that flatness. And so this piece of software the spectrum analyzer, RSP spectrum analyzer, worked out a hell of a lot better than I thought it was going to. I really never had a chance to play with this. So I'll show you what this looks like. I'll just flash to these pictures here, you know, for a couple of seconds so you can see what they are after I finish this long blah, blah, blah. But what this does is it allows you to have noise everywhere across the spectrum. But then you put something in the line and you say, well, I want this, I built a notch filter. How far does it notch? How deep is the notch? How wide is the notch? Do I have to work on it? You know, so if you don't have a tracking generator, if you don't have a nano VNA, and you just have an RSP DX or Uno or one of those, I don't know every one of the receivers that this works on, but it works really great. So the first thing we'll do is we'll set this up with nothing in the way. In other words, nothing in series with this and the spectrum analyzer software. And you'll see essentially what you might expect, a flat line of noise, right? Then we're going to put in this notch filter, and this is a crummy notch filter, okay? So you'll see how bad it is, how wide it is. It has plenty of notch, but it's very it's very low Q, so the notch is very broad. And then we'll take a look at the high pass filter I made, and then we'll take another look at the low pass filter that I made. Again, I'm not any sort of expert on this. I just saw this today, but I figured, holy cow, this is so important that a tool that people can use to do some real measurements without having to spend a ton of money on anything or the complexity of the nano VNA. So I'm going to show you a couple of these pictures here right now. And then we're going to go over to the ham bench and, go through kind of a tutorial on it. Not a tutorial, but we're going to sweep all these items and you're going to see what they do. Okay? Any questions? I didn't hear anything. All right. I'll be back in a couple of minutes. Right now I'm going to show you the close-up pictures. All right. Quick overview here. This is a kind of a blown up picture of the noise generator, 12 volts in over here, and you can see the MMICs here to get us about an S9 level, a little bit of impedance matching. But the most important thing is that this is a nose source, so don't forget that. I guess everything doesn't come out into translation. You can look up this part number and find this online. So anyway, that's the noise source. All I did was screw it down to a board for this experiment. And here's the noise diode right here, and then it drives, or it could be here. I think, yeah, this is a power supply diode. Make sure you don't hook it up backwards. But here's the noise diode, and then it drives all these, okay? So we'll move this right along. The AM W1 VLF AM high pass filter, nothing really spectacular. BNC in and out. That's one of the devices we'll be working with. And here's that notch filter. It really is horrible. It's just a loop stick with the appropriate number of silver micas on the side here, the capacitance value to get it to notch around 610. And really, the Q of the system is low, and you'll see that when we go through the spectrum analyzer. And then, of course, the W1 VLF low pass filter. I threw this together today really fast, and I didn't play around with components to give it a nice flat band pass. So, kind of disregard how that looks. Anyway, those are the 4 pieces, and let's go over to the ham radio bench now and see what happens. Okay, we're over here at the ham radio bench. There it is, plugged in, the noise generator. And right now, we're going patched into the attenuator, and then over to the RSP DXA. So let me jump on the microphone and set everything up, and I'll be right back. Okay, W1 VLF back here. So here we are. this is the page I downloaded the spectrum analyzer from, and we should give a big shout out to Steve Andrews, who wrote this stuff, because it's really excellent. And it looks like an RSP1 all the way up to the Duo is now supported. So thanks for that. Wow, fantastic. Here's the download link. And then you do your normal downloading, however you do it with your computer and equipment. And what'll end up happening is you'll end up with an icon like this. Little tiny icon here, RSP Spectrum Analyzer. I already have it open, so I'm going to fire it up. And you're going to end up with a blank screen like this. You're going to have to choose what receiver you want to use. I'll stop this for a second here. So when it's stopped, you're able to pick I have only two connected, the Duo and the DX. So those are my only two choices, and I'm going to use the DX. What am I using? I'm using antenna A input. Okay, and I'm going to start it, and you can see it running here at the bottom of the screen. I have the input right now terminated in 50 ohms. So there we go, right? Okay, now what I'm going to do is unterminate it, connect to the patch panel, and there's our noise. So where were we before? Minus 120 or so, and we have a plus a minus 60, which is 10 over S9, a little more than that. So we have plenty of output here to play around with it. So let's mess around with a few of the controls first. This is there's several screens that you can have here. I'll turn on another one. I'll show this one. Now you have the white screen and the red screen. For instance, well, let me do this. Let me hide this one, and we'll do an average on this. Okay, this is a smoothing function, so you don't see as much of the noise. How do you average? You turn on the averaging function, and you pick how many averages you want. All right, so we're just going to leave that one alone, and we're going to grab number 2, and that's not averaged. We're going to do a peak hold on that one. Whoops, I was in the wrong one. So let me go back to here and do take off the peak and do an average. And then the second trace, I'll do a peak hold. Okay, so where are we? What frequency are we on? Well, the bottom of the band starts at 1.2 megahertz, and the top of the band is 2.2 megahertz. So 1.2 megahertz down here and 2.2 up here, as you can see right here. So this is flat. This is within a dB or so flat, and so we're not going to get the same results out of a precision tracking generator and a precision spectrum analyzer, but this is still a really great way to do this. So let me get rid of this one. And I'm going to take off the averaging, and I'll just go to raw. There's our noise. Okay, again, with this off, our noise floor of our instrument's like minus 120. Plug the noise source back in again, and we have about 60 or 70 dB of difference there. So what's next? Next thing is I'm going to take the AM high pass filter, and we're going to put that in. And I think it's going to start to roll off down, eliminating the AM broadcast band around 17 to 1800. I don't remember this filter that well. It was a long time ago when I made it. But anyway, let's put that in line. So we'll pull off the noise generator, plug it into the high pass filter, and now we're going to plug it right back in again. Okay, and you can see that, and let's just talk about this for a second. You can see that, okay, wherever that other line was, here, this is a better way to do this. I'm going to take and I'm going to insert the noise. I'm going to show number 2, and there's our averaged noise for number 2. Now I'm going to insert the high pass filter. Okay, and you can see, and now we're going to do an average on, or an average on that. Okay, we're smooth it out. How much did we smooth it out? Well, let's see. We're only smoothing it out by 2 averages, 10 averages, or 100 averages. You have to wait a little while. So let's take a look. Down here at 1.2 megahertz, it's minus 118, almost minus 120, and it probably is if I change the if I roll this down a little bit further. Nope, I'm going the wrong way. First, you have to take the averaging off. Otherwise, it'll take you forever to get there. Let's go to 2 megahertz of bandwidth, and we'll disconnect this guy because that's no longer valid. All right. So with 2 averages, it's a little kind of hard to look at. So let's go to 50 averages, and we start to see a pretty good idea of what's going on. So minus 68 with a roll off into the AM broadcast band of minus 120. So huge numbers here. This is fantastic. And let's smooth it out by going to averaging 100, and we'll take a look and see if that really buys us anything. It takes a little bit longer, but at least it might buy us a really smooth trace. And this is nice. This is typical of what I see. There's a little bump here right as you move into the knee of the filter, and that's, you can see by my marker here that that's minus 68 dB. And as I go into the AM broadcast band, and as I go down to, let's go right to here. By 1200, it's down 120 dB. And this is what I mean about not really knowing how to run this perfectly. I'm going to try to bring up that bottom end a little bit. Let's see, I think I need more dynamic range here. Reference level, let's go to 70, 80 dB of dynamic range. Okay. Now we'll go in and we'll use that averaging function. You could see, again, 64 dB here. Minus 64. That's still 10 dB over S9. And down here is minus 117. Let's put in the filtering, the averaging. We have it in, but we're only doing it by 2. Let's take a look. Give it a few seconds to average out. So somebody could do the reverse math for me, because I find it really hard to do this. Minus 69 minus 70 all the way down to minus 122. So what's that? 22 plus 40. So it's 60 dB plus of attenuation with that particular filter. Okay. Fantastic. This is great. I mean, this is like we're in heaven here for guys who are working on lower frequency stuff. Now, the other thing I didn't mention is this noise generator goes up to about 50 megahertz. If you check on eBay or wherever you're going to buy this from, they'll give you the specs on it. It'll be plus or minus a couple of dB across. I mean, a really expensive multi-$1,000 noise generator is going to be flat within a couple of tenths of a dB over hundreds of megahertz. But this is a $13 item, and as you can see, that filter really it's really kind of nice. So let's go right here, 610, and we are down 124 dB at 610 kilohertz, and we are at minus 70 or so, few dB over S9 right there, and actually better 10 over S9 all through here. So let's take the averaging off, okay, and we'll pull out the filter now. Now, this is the part that Glenn, W2BX, would be interested in. Oh, son of a gun, I forgot the filter in the other room, and I'm going to have to go get it. Give me 30 seconds. All right, I suppose I could edit that out, but this is live. So let me take this wire off here and terminate the input. So you can see the input is nice and flat. I'm terminating the input of the RSP DX. And again, you could use your RSP1 or whatever. Let's see. Let's just real quick go back to that page. RSP1, 2, Pro, 1A, DX, and the Duo. So lots of really cool options here. Okay, so we're looking at a minus 125 here or so with the input terminated. Let me put the notch filter in place. Now this notch filter is centered at 610 kilohertz. So what am I expecting to see here? Let's go back into the DX. All right, and 610 kilohertz is off the screen, right? Because I'm only going from 800 to 2.8 megahertz. So let's go over here and roll it down. Let's go to 610 here. Oops, I don't know, how do I do that? How do I get rid of that? Oh, okay. The start is at 600, is at 0 kilohertz, which is what all this noise is. And the end is at 2 megahertz. So there's our notch filter, okay? So let's see. Up here is usually around minus 68. That's what the output of the generator is. And personally, I like to see some smoothing going on here. Now, the smoothing might change this, inevitably change how deep this notch shows up. But let's go to 20 times smoothing and see what this looks like. Again, this is the crummy notch filter, okay? So here's 610, and we have 40 dB or so of notch, something like that. I don't know. You could do the number. Well, we could do, let's say that's almost 10. So let's call it 10, 20, 30, 40, around 40 dB a notch, plus or minus, all right? I'm not trying to make some actual real world measurements here. But let's go up to look at what happens here. We're at 1400 kilohertz, okay, and we still have 5 dB of loss. At 1200 we have a truly 5 dB, and then at 1000 we have 10, and then at 800 we still have quite a bit of loss. So I'm going to move this filter. I'm going to tune it by that little screw, and you watch what happens. Okay, I'm tuning it. I just tuned it. Let me take away some of the filtering because that'll cause it to not move as quickly. All right. But here I am moving that. So, I mean, you could actually tune things with this. This is absolutely incredible. I'm in love with this program. That's not true. I'm in love with my wife, not this program. But so here's 600 and let's go to 610 is right here. So I want that notch basically on this line. Okay, so we're going to move it to that line. Okay, a little more, a little more, a little more. Okay, so that's right about, and now we'll go in and do our filtering again. I'll clean that notch up. Okay, so with 100 times averaging, you get a pretty darn good idea of what that notch filter is doing. And this is a horrible notch filter. What I'd really like to see is this thing look like a really steep and then come right back up again. And the higher Q notch filter would definitely do that. All right, so let's get rid of our averaging here. Excuse me. Go back to raw. Let's take this device out. And now we're going to put in the W1VLF crummy low pass filter. What are we going to expect here? We're going to expect to see this drop off around 300 kilohertz. It's precariously hanging there. Okay, so Let's see here. And this is what I mean by terrible. Yeah, I really didn't spend any time on this filter, but okay, so here's the roll off. Okay, let's see what it does. And here's the pass band, and now we're going to go and do our averaging again. Let's turn that on because I can't stand seeing it that bad. But it's going to show you all the inaccuracies in that filter. So let's see, where does it roll off? It really starts to roll off at 360, and by the time you get down here, you're down to minus 120 again. So this is really great. I'll tell you what, let's do one more thing here. I'm going to show that, and I'm going to take the peak off. I'm going to go back to raw. I'm going to filter this, okay, by averaging it with 100. And it's going to end up laying right on top of our other trace. And then we're going to hold that. Right now we're going to hide it. And we're going to take this filter out. We're going to put the notch back in. Let's put our notch back in real quick here and do another experiment. Okay, so get rid of our averaging here. Okay, oops, there's that notch starting to show up at 610. Let's see if I can do this. And we want to go to, I think, a megacycle here, right? Yeah. And we're going to now go and do our averaging again. And you say, okay, well, that's a nice notch filter. Let's go show, oh, there's the other filter, the low pass. And just for the hell of it, let's hide both of these. We're going to show this one, and we're going to put in the wherever it is. This filter. This is the AM high pass filter. Now, let's see what we got here. Okay, so it's not going to give us anything down here because this is all inside the AM broadcast band. So if I move up in frequency here, there's our shoulder. Okay, let's do the filtering. Turn on average. Beautiful. Now, I'm not sure, because we're out of band here, if this is going to show or not. But, yeah, there's our... It doesn't show the exact frequency, because remember, this rolled off at 360 kilohertz. And this notch, which is the first one, up, average. Well, see, I screwed it up. I instead of putting it into hold, and seeing what that was before, I messed it up. Anyway, I just wanted to demonstrate this program by Steve Andrews. This is fantastic. Like I said, I really enjoy this program. And if you enjoy this kind of content, I put something in called Super Thanks. And what it is if you want to donate a little bit to the station to help offset some of the time and things that we build here, I would certainly appreciate it. YouTube doesn't seem to want to they literally make pennies on a video. So it really would be helpful if somebody could maybe throw a buck or so in this direction. So anyway, there it is, W1VLF. Please subscribe if you like this, and we'll talk to you later. W1VLF out.